45. Let's get started. Welcome to the next session. We're going to talk about profiling. I'm going to give an overview, an introduction about the FHIR Conformance layer. I have a lot of sheets, I have a lot to discuss. Maybe we have time for questions. If not, you can find me after the events in the room. So, who am I? My name is Michel Rutten. I've been working for FHIR for about 5 years now. I joined the FHIR team. I make a profiling tool. So profiling is kind of my specialization, and that's why I'm giving this tutorial. My specialization is mainly in .NET, so don't start asking me Java questions, because I won't know. I'm going to try to discuss all of these topics, time permitting. I'm going to give a little overview of the conformance layer. We're going to focus on profiles, that's one of the most important parts, and extensions. And then I hope I can talk a little bit about implementation guides and the FHIR profile registry. So why do we need profiling? Well, FHIR is a platform specification. As Richard in the previous quarter just explained, it provides these building blocks that you have to constrain them to your use case. And that's why we introduced profiling in the platform. So you have to adapt these resources to a specific use case, profile the resources, and document that. Further adaptation to a context of use, that's what profiling means. So, which resources do I use in my use case? Which elements are important and which aren't? Which API features do I require in my use case? Which operations, which search parameters, for example? Which serialization formats do I require or do I support? Which terminology bindings do I support? And how do I map these to my use case? And then FHIR provides technology to author that in a structured manner. This will be the recurring motto of this 45 minutes, structured. Independent of the serialization format, of course. And you want to publish that in a repository because eventually someone's going to implement that system, so you're going to publish it somewhere. And because it's structured, we can use it not just to read it as a human, but also to feed it to a computer and do all kinds of cool stuff like validation, code generation, form generation, etc. So first, an overview of the resources specific for conformance. FHIR provides about 120 resources and it's growing and growing. And this is the set of resources that are specifically intended to be used for profiling. On the left side, you can see some terminology resources, the most important one being value set. I won't discuss them here, but it's an important part of profiling. There's a different track discussing terminology. The main one, you can see in the second column on the top, structure definition. That's how you express, we constrain elements and resources. That's actually the main part. You can express mappings. And then we have some resources for operations. Here you can define the capabilities of your server. What kind of operations do I support? What kind of searches do I support? You can pack it together with a capability statement. And finally, you can generate an implementation guide and use test scripts. And that's what Richard from Regis is all about. There are a couple of more, but these are the main ones. So structure definition. What's a structure definition? It defines a data structure, of course, as the name says. It defines the core data types. So for example, a FHIR patient resource is defined by means of a structure definition. And the data types, for example, FHIR has a codable concept data type. That's defined by means of a structure definition. You don't just define resources, you also constrain resources using a structure definition. So on the second level and below, you use a structure definition to further specialize these resources. You can author an extension that might have multiple elements. That's a structure definition. And you might even create a logical model. That's a structure that's not related to a FHIR resource at all. That's just a virtual structure. So what can you do with the structure once you created it? Well, you want to publish it, you want to share it so people can implement this interface. You can compare structure definitions. You could even write some very smart software to do that for you. You can transform or maybe strip elements, remove them, because it's all computable. You can use them to validate. If a structure for a patient and you send me some patient data, I can validate it using that structure and see if it conforms. I can use it to generate code. So I have a patient structure, I can use that to generate a patient class in .NET or Java or any language. And you can use it to generate a UI. So from that patient resource, I can generate a patient input form. And all of this is driven from code. Again, because it's computable. There's a recurring theme. So a second conformance resource to operation definition, and that's a way of describing capabilities of your server. My server supports a read on a patient. My server supports, you can update a profile. My server supports, well, maybe something special. You can do a snapshot generation or expand the value set. Maybe you even have a custom operation that does something like handle an insurance claim or something. And you can define these again in a computable way. So you have discovery. You can write software that discovers the operation of the server. You can define the parameters, the behavior, and extend the API. You can do the same for a search parameter. My server supports search on a patient name. My server supports search patient by identifier. And this all packs together in a capability statement. So all these different types of definitions, you bundle in a capability statement and you publish it from your server. And then you say, my server supports these and these serialization formats, these and these search parameters, these and these resources, and these operations. And again, the whole thing is computable. So you can write a client that dynamically discovers the capabilities of a server. Everything is bound together in the capabilities. This is a large beast. Usually on the first request to a FHIR server, you check if the capability statement provides everything you need. But that can be quite large. And then with an IG resource, when you write an implementation guide, you don't need to use the FHIR resource, but it might provide some extra support if you want to use tooling to create implementation guides. So that's there. And here you can see how they all relate. Typically from a server, you publish your capability statement, and it includes references to all these different types of resources, and that's how you define the behavior of the server, or how you describe the capabilities that your use case requires. You can imagine you can have a negotiation on capabilities. And it's used in the core spec. So FHIR uses these resources to define itself. The core data types, the resources, the REST operations that are standard available in FHIR, the standard search parameters, and the terminology. So FHIR bootstraps itself from the famous Baron von Münchhausen. Or another way, we eat our own dog food. And that's how we improve the standard, because we use these structured definitions to build FHIR. That's how we tweaked even these conformed resources, because we discovered we needed more, or it wasn't convenient. How do we refer to a conformance resource? The conformance resources are a little bit special. If you put a patient record to a server, that's usually a unique instance. But with these profiles, you're going to share them, so you're going to expect that these profiles, copies of these profiles will exist on many servers, or maybe within your local environment, or you hit out to a network. But we want to give them all the same identifier. So for these conformance resources, we have a notion of a canonical URL. I found this little picture on the internet. So they're all copies, and they're all similar, and they all share the same canonical URL. They will have different IDs, but that's just on different servers. So when we're talking about conformance resources, we're always talking about a canonical URL. And that might exist on different servers, but they all have the same canonical URL, and that's how you know it's the profile you need, right? So it's the, I say URL, but you should read URI, Uniform Resource Identifier. Yes, that might be a location, but always this is used for identification. So the canonical URL, think canonical URI, but don't really use them. So as an example, I have a structured definition for a Dutch patient that exists on 3 servers, one in Europe, there's a copy in the United States, and there's a copy in China. They all have different resource identifiers, and the server just assigns that, so that's out of my control. But I need to reference to these things, so they all have the same canonical identifier, and that's how we know it's the same profile. So let's go deeper into profiles themselves. So this is the structure definition. I'm going to skip all the other resources and now focus on the structure definition, because that's the core. As I mentioned before, a structure definition is used to define the FHIR core data types. like the patient, like a codable concept, and even structure definition itself is defined by means of structure definition. So that's the bootstrapping process. And you can profile another profile. So I can profile patient and say, well, these are the special rules in Holland for the Dutch patient. And then within an organization, you can take that Dutch patient profile and put in extra constraints and say, well, within the organization, I'm going to be more specific, right? Trick question. What's the difference between a resource and a data type? Raise your hand for bonus points. Anyone? A resource exists on a server, identifiable. A data type only exists as being part of a resource. So you can't publish a string to a server and expect the server to assign an identifier. It will reject it. You can't put a string inside of a patient and send that patient to the server, and it'll give it an ID. So a resource is a component that you can put to a server and get back. A data type is always part of a resource. It never exists standalone and it doesn't have an ID. You can't send a boolean to a server, for example. That's the difference. But for the rest, they're the same. The data type can have multiple elements. And then there's a little overload. You have to take care. When I use profile, I use it for constraints on a resource or a data type. But some people use the term profile to refer to an implementation guide or a performance package. So just be aware this term is overloaded, and you have to take care of the context what people do mean. Implementation guide might be a set of these constraints. It's used on multiple levels. Here's an example of this labeling of profiles I was talking about. The most generic ones are the core profiles on the top. They're most flexible ones. That's what the standard provides. And you can start constraining them, for example, on a national level, or you can move down to a regional level. For example, in Norway, there's some clients where they have national profiles, and then for certain regions of the countries, they put additional constraints on that. And then you can move down into your organization and further constrain it. If you look at the resources that map to these profiles, they become smaller and smaller, because once you start adding constraints, that's like a where clause in a SQL query. The number of resources that matches diminishes, right? So the profiles get more and more specific, and the resources on the top are the most generic, and here they're very specific. So what's in a structure definition? Well, you have some basic metadata, canonical URL, because we need to identify the thing. So you have to put a unique identifier to it. A name, a title. All the conformance resources have a status field. You have the date and the version, author assigned. And a reference to the base profile. I'm constraining the Dutch national patient, so you can point to that other profile. And then the core then follows a list of element definitions. The patient has a name. That's a human name data type. And the patient has an address. That's an address data type. And the patient has a status, and that's some coding, for example, or a Boolean field. And the patient has a deceased field, that might be Boolean or date time. So you have a list of all the elements with the data types, with their cardinality. How many times do I allow this element to occur in an instance? You can put on definitions. So this is narrative. You can fix the value. You can add terminology bindings. You can add complex constraints where you relate. If you enter this field, you have to specify that one. And you can map these elements, for example, using the RIM model. So how do you refer to a profile? Let's assume when I exchange an observation. This is a concrete observation on a patient, a cholesterol observation. What FHIR allows you to do is put a tag on that instance. So, for example, a client application has an input form where the doctor enters these values, and the client application puts a tag on it and says, this is an LDL cholesterol observation. I know the profile that exists within my organization because we created it and it's on our server. So once that data hits the server sees that tag, and it can try to resolve that canonical URL that uniquely identifies the profile. So the server will find that profile identified by this canonical URL, and now the server can validate the input message and see, because the tag is a claim, Well, I can claim to be a woman, but you have to verify, right? So it claims to be an LDL cholesterol observation, but you can claim everything. You have to verify. You can use the profile to verify that claim. And when validation succeeds, the instance is accepted and stored in the server. And if it fails, then the server will reject that data and say you didn't do what the contract requires you to do. For example, you're missing a required field. No? A bit about versioning. There is an author-assigned version field on the conformance resource, but that's not used by software. The software we built uses the canonical URL, and that identifies the contract. So once you publish a profile and you put on a URI, then that's a promise for eternity, and you promise to implementing parties, this is how the system works, and it's a guarantee, and you shouldn't change it anymore. You can tweak the profile. For example, if you find a typo in a comment, you can correct that. That's not a breaking change. And you could change the author-assigned version, but it wouldn't change the meaning of the data. So that's a compatible change, but those are small corrections. If you need to apply a breaking change, add a field, allow extra extensions, maybe remove some stuff, then the contract no longer holds. And then FHIR says you have to publish a new profile with a new identifier. So all the existing systems still operate against the existing profile, and new systems can start to support the new profile, right? So if you make breaking changes, you have to change the URI. Of course, you can do anything, but because it's computable, we can verify. So even if you don't do it, you can write software that validates it and see if you broke the rules. I'm going to skip this one for a moment now. So how do you author these profiles? Well, FHIR has these serialization formats, and you could write them by hand in an editor, XML, JSON, or maybe even RDF if you're really adventurous. Or, well, at first when FHIR started, there wasn't any tooling, so there was an Excel sheet. And they tried to map a tree onto a grid. That's an inconvenient mapping. So it wasn't fun. Don't try this unless you're in for some pain. Fortunately, there are tools. Lantana built a tool called Trifolia. That's on the market for quite some time. We're mainly focused on CCDA. Rick Geimer of Lantana, he's here, so if you want to know more about Trifolia, talk to Rick. He's the guy with the ponytail. The second tool is MBHT. That's a UML base, so they try to map FHIR onto familiar UML concepts. And you describe the model using UML, and then the tool transforms it into a FHIR profile. There's also a free tool. Again, I noticed that the author, Dave Carlson, of this tool is here at DevDays. So if you want to know more about MBHT, check out Dave Carlson and talk to him. And finally, there's Forge. That's a tool that I create for my company. You can download it for free. Forge was specifically created for FHIR. The other two tools, they have a longer history, and they started supporting FHIR, and Forge is specifically for FHIR. It doesn't do anything with V2 or V3. So a little bit of extensions. Well, these resources out of the box, they might not support all the elements that you need. Because sometimes you have a need to add an element. A very famous example is patient race and ethnicity. If you look at the United States, it's mandatory to register this information. If you look at Europe, it's forbidden to register this information. So clearly this can be part of a FHIR core patient resource, because there's confusion. So race and ethnicity aren't part of the out-of-the-box patient. But in the United States, you need this, it's required. So what do? You use an extension. And again, these extensions are published. So HL7 has created a patient race extension, has created a patient ethnicity extension, and they published them. And these were standardized for the US realm. And you can create your own extensions. For example, we did a lot of these extensions in Holland now by HL7 NL and NICTIS. So you have to define it. Again, an extension, how do you define it? It's a structure definition, because it's a data type with one or more fields. It might be a simple Boolean, or it might be a pair of coordinates, or anything. As all profiles, it has a canonical URL, because you need to refer to it. Say here, I'm specifying patient race, and what is it? Look at the definition that's published there. And define the context. So clearly, race and ethnicity, these extensions only make sense if you use them in the context of a patient. It makes no sense to put that on an observation or condition. So an extension can specify for which resources am I intended to be used. And you can reuse the extension in many profiles. For example, well, you can create extensions that fit onto multiple profiles. You could create an extension that applies to patients, but also to persons and also to related persons, for example. You can express that. So by default, FHIR allows any number of extensions. The FHIR core resource, like a patient, says you can add extensions on any of the elements, and I will allow it. I'm fine with that. So if you exchange FHIR information in a generic sense in a server that doesn't use any profiling, you can slap as many constraints on it as you want, and the server will accept it. But maybe in your situation, you have a system in the backend, and it probably is not capable of handling all the extensions in the world. Probably your system can only handle a couple of extensions that you know about. So you want to constrain this. And that's what FHIR allows you to do. So in a profile, you can say, I'm going to require this special patient race because it's mandatory within my country. I'm going to disallow other extensions because the system wasn't built for these extensions. I don't know about them, I can't store them, I can't handle them. And you can constrain it in the profile. You can require extensions, you can disallow extensions, you can say, I accept random extensions, or I don't accept extensions at all. So how does it see in a profile? Here we have an example of a patient profile. It's Irma from HL7 Holland. Some of you know her. And here we put a nationality extension on the patient. By default, a patient doesn't have a nationality field, but in Holland we want to exchange that information, so we put an extension on it. And there's an out-of-the-box, actually an official nationality extension called HL7. So this patient has a tag on it saying, well, this is a patient record that conforms to a Dutch patient profile. And in that Dutch patient profile, there's a definition of an extension element. First, there are constraints in all the regular elements. Maybe there are some special constraints in the name because we have funny names in Holland. But eventually you end up at nationality. That's not out of the box. That's an extension element. And the profile defines that by saying, yes, you can send me a nationality. And for the rules, check that external definition. So the patient points to the nationality extension. And there can be many of these extensions, and they're all defined externally. So you don't include the definition in the profile. All these elements have separate definitions. And you can publish it. So you have a very simple extension is, for example, a birthplace or birth time. That would be a string field or a date time field. It's just a simple primitive type. Many extensions are primitives. But it's possible to create a complex extension. And for example, patient nationality actually is a complex extension because it has a code which is complex of itself, and it also has a period because you might have moved in between countries. So this is an extension that has multiple child elements. If you put that on a patient, you get a little nested data structure, right? So, a little bit more about implementation guides. All these profiles, why do you create them? Because you want to publish a contract, so implementers can build that interface. Well, if you have a use case that uses a couple of profiles, they're related, and a couple of operation definitions, and a couple of search parameters, and they together describe your use case, then FHIR provides an implementation guide resource to do that again in a computable way. So you can reference all these performance resources from the IG resource, and this way you can exchange this related information as a set, because they belong together. Conceptually related artifacts. And the references. Again, the IG points to these resources. The second part of the IG, because people want to actually read a document, they don't want to look at XML and JSON, so an implementer needs actually a story. You want to tell them how to do this. I'll give them some examples. So the second part of the IG, you can put in pages with some formatting. HTML, Markdown, whatever you prefer. And then the IG resource lists these pages and it lists the structure in a tree. So it has two phases. It's a set of reference to the profiles and it's a list of pages. And of course they relate because this narrative describes the profiles. Now, of course, you can exchange it. Maybe you have separate publication environments. There's an official implementation guide registry published by HL7. Maybe you want to send it there and publish it so the whole world can read it. Put it in an IG resource, send it to that server, and it will know how to deal with the information, how to publish it. And you can render it. An interesting thing is the FHIR spec, that's rendered. People write these resources. Within HL7, people tweak the resources leading up to R4. There'll be changes. But this is a computable process. So the whole spec, there's actually a tool behind that generates all these pages driven by the resources and combines the resources and the narratives and generates the website. And you can do the same for your use case using the IG resource. And you can use it to validate, because an implementation guide groups together these related resources. Together, they are sufficient to validate the information in a specific use case. So how do you author them? There's a tool put out by HL7 FHIR itself, the IG Builder, and that's a command line tool. I think it's a Java tool. And you put all your profiles and all your pages, your narrative in a folder, and you run the tool, driven by some config files. And it'll take a little while, and it'll generate a website for you, like the FHIR website. And you can find, for example, DevArgonaut, that's a standardization project in the United States, and they use the tool to generate their own IG. And if you Google DevArgonaut and you look at their implementation guide, it looks very much like the FHIR spec. So you can see they use that tool to generate it, and you can use that tool. Or my own company has created an online platform it has the same intent and purpose, but it's a different approach. This is more an online environment where you log on, you create pages, but you end up with the same. You enter your profiles, you upload them to the environment, you upload the narrative content, or you have an online markup editor, you enter the pages, put them in a structure, and then finally you have a publish button, and it renders the whole thing for you. And for example, HL7 Germany published a very nicely rendered implementation guide on the platform. You can find it on there. And the guys from DevDays and FHIR, they're here, DevDays, they're doing pretty cool stuff on the platform, grouping complex device profiles together and validating them as a set. So they're really at the edge. A little bit about workflow. You can expect that while you're creating these profiles, maybe you're collaborating with a team and it takes a couple of weeks and you're exchanging draft versions. And everybody's contributing to the discussion and you find bugs and you fix them, and that's kind of a workflow. And then finally, somebody says, okay, you decide this is the final version, now we're going to give it to the outside world. Now we're going to publish it so people can implement it. So you publish the interface. Now the canonical URL becomes definitive. It leaves your own organization, you put it up on, for example, on a registry. That's the promise. So now you can't change the URL anymore, now you can't introduce breaking changes anymore, but you can start working on a new version. So while this first version of your implementation guide is being published, saying, this is how we do, I don't know, use case X in 2017, and then you already start working on what's coming in 2018. So while implementers visit this published version, this final version, your team starts working on the next one. And then finally, in the next year, you're going to publish a second version. And then maybe eventually, you're going to retract the first version because it's no longer supported. So there's this notion of workflows. You have an editing workflow, and you have a publishing workflow. And you have this, that's not just implementation guide. You can see them in all the resources. So one of the things to keep in mind when you start is, think about versioning. Eventually there will be a second version of the profile. And it makes sense to have a strategy in advance. So the registry. We want to publish these profiles somewhere, but if everybody publishes their profiles on their own website, we still have a discovery problem. So we need something like the Google for FHIR, where everybody knows where to go and where we know where we can find all this published content. So that's why FHIR put up a registry. It's located at registry.fhir.org. It's live, you can go there, and you can find all the official profiles. So the registry contains official FHIR profiles, official HL7 FHIR extensions like patient nationality, vital health profiles, observation, stuff like that. And also profiles created by the working groups. But of course, you also want to publish the profiles. Oh, there's also an implementation guide registry. So this is where you publish the resources. This is where you publish the narrative, the IG. Here you can download the structure definition, and there you can open readable pages in the browser. That's the difference. But you can also go to simplifier.net, and that's open to the public. So the HL7 registry is only open for official HL7 profiles and working groups, and the registry is open for everybody. So here everybody can share their profiles. Of course, you can also publish an IG in your own company network, but it makes sense if everybody starts searching in the same registry, because how are we going to drive interoperability if we're all going to create our own profiles, if we're all going to create our own extensions? So the standard tries to encourage you to first search the registry for prior art and use that if it exists before you start designing your own extensions, right? And actually, this environment is the backend for the registry. So the official FHIR registry, that's just a publication system, and Simplifier is the backend where you author this stuff. I won't be discussing tools. In the booklet it says I'll be giving a demo of Forge and Simplifier, but I don't have time for that. So that's in the next session by my colleague, Vadim Petropin. He will do a demo of all the profiling tools. Not writing by hand, the horrible stuff, but show you that there's pretty nice tooling available. We have some profiling exercises. I have a stack of them here, so please come up to me if you need them. They'll be at the table and at the registration desk. There's also a Profiling Academy on Simplifier. If you go to the homepage and check the link, with a bar at the bottom, and there's a link to the Profiling Academy, and that goes into more detail on all the stuff that I now introduced. And you can find more exercises there. Time for coffee, unless there are questions. Anyone, don't be shy. Please.
Hang on.
A server publishes a profile. Sorry,
Sure.
Does that mean that it will reject a client sending data from another profile? Is that necessarily the case? Or does
Yes.
it specify interoperability? You say I can accept this profile, this profile, this profile.
It's a decision of the one configuring the server. But in a simple case, the server will just support patients, like Dutch patients, and if you send me an American patient, you're going to reject it. You can have a complex server that accepts patients conforming to multiple profiles.
Okay, so you can define that I accept patients conforming to these profiles.
Yes, and you do that by means of the capability statement. And that's very granular, so you can be very precise on what you do and do not accept. Good question. Other questions? Please.
When you unpublish, don't you effectively break existing contracts and software?
Yes, yes. You should. That's why I had this little comment. As a developer, we should see once you publish an interface specification, that's a promise for eternity, because people start building software against it and can't retract it. In practice, you will see that governments will eventually retract certain standards because the law changes, the world has changed. But you need to do it in a controlled way. Probably that's announced way in advance. You say you want to retract support within 5 years from now. You can't just retract the profile randomly. That would create a huge disturbance. Yes. Other questions? There must be. I have many questions about this because I'm just scratching the surface here. So,
yeah, I have another question about the profile and the validity of profiles over time. Say, for instance, we use an NL profile, and I want my own patient profile, but I look up the NL profile and say, okay, that will do for me. So they will never be able to change it. And how do, for instance, if the NL profile, they want to update on it, how do they do it, and how do I keep up with the validity of the NL profile if it also works for me in the update?
oh, this depends on the author. Usually, once you publish a profile, you're very reluctant in introducing breaking changes. You only do that if it's actually necessary. I know in Holland that we have, I think there was the first example of a breaking change in a published profile just because the law changes or you need to follow changes in the real world. But it hurts. How do you make sure? Usually you have a migration process. You can, all the data that exists in your server that's already been verified against the existing profile, and that verification stays. You can be sure if all that data also conforms to the new profile. What you could do is rerun the validation. It might fit, or do a transformation of the data. So, oh, the new profile is a new required element, so I have to go through all the records and submit that data. But it's not an easy answer. And it depends very much on the use case. Please. Question in the back?
Interesting talk, especially about profiles and on what level you do what. But we were in our own radiotherapy clinic working on it, and you mentioned like you have these core profiles, national, regional, institutional. But if you have specific demands for a kind of hospital department, let's say, and you want to store specific information, where would you tackle it in that hierarchy? Would you do it on the organizational hospital level, or would you go to the highest level of the core because it's maybe generic for that medical specialty, or how do you want to place that?
We can change the core, of course. If you want to change the core, you have to be part of the HL7 process and go through the ballots, so that's a slow pace. You can change the profiles under your control. So it's in the drawing I showed 4 layers where it went down to organizational level, but it's certainly feasible to even add a 5th layer and say, and within certain departments, we're going to add more constraints. So for example, you have specific profiles for cardiology, or specific profiles for patient care.
But if you put it below the actual department or organization, then it's specific for that department, and you want to share that across multiple departments which have the same problem.
Ah, right. Yeah, this is, as Richard mentioned in the previous scene, FHIR provides a compositional approach. You have these granular resources, and usually your use case won't fit one-to-one in a single resource. Usually you will have to search like 4 or 5 resources. So these common constraints, usually they're put onto data types or extensions or some resources, and they will be reused across departments, but they will tag on their own resources or modify part of it. So a good example is an address. We have in Holland, we have some special rules on addresses, and we need to reuse the data type for contact information of a patient, contact information of a practitioner. You can find it in related person, or there are different parts, and on all these parts, we put the same profile constraint, saying you need a Dutch guys, a Dutch guys, a Dutch guys. And that has a single definition in the address profile. So does this answer your question?
Final question?
No, just a comment on this question. It usually goes the other way around. If you have a department that is creating some profile, and you go with this profile, you want to go national or regional, you will need to reach consensus. And it will be a difficult process. So you begin with your own profile at the regional, at the department level or organizational level. You will make that work, and then maybe you could convince other people to use it. So you will go regional and then national. you may be very lucky and have things going top down, but usually it doesn't happen, at least in my experience. You first do something at your level, and then generalize.
It's a great contribution. Thank you, Diego. Yes, so you have a top-down approach, but you also have a bottom-up approach. I see one more hand. Is it allowed? I don't know.
If you want to make extensions for specific, if you want to make restrictions or extensions for specific use cases that are shared amongst different departments and different organizations, you can also apply multiple profiles, right? Or not? Is it?
It is, yes. In the example I gave of that patient that had a tag on it, or was it an observation with a tag saying, I'm a LDL cholesterol observation, I conform to that profile. You can put multiple tags on an instance. So I could say, well, I'm a generic Dutch patient, but I'm also an Amsterdam patient, and I'm also a FHIR patient, and I can put all these claims on it. And then the server could verify all these claims. It makes your use case a lot more complex. You have to think, if you give me one profile, I can generate a class, and I can generate an input form. If you give me 3 profiles, that becomes kind of hard. So it has implications, using multiple profiles in the same instance, but it's very much possible. It's also possible that you are conformant to all kinds of profiles that you don't claim. So if I just input a name and a number, I might conform to the Belgian patient profile. I'm only claiming that, but if you check it, it might be true. So you could run an instance against a list of profiles and discover against which profiles it conforms. So lots of flexibility in the model on what you use in your use case. Depends. I think this is the last question. Thank you very much.